Welcome, welcome, ladies and gentlemen, here at the Hannover Fair of 2023. We are at the Hydrogen and Fuel Cell Forum, and you're visiting the technical session. So we have many experts here on stage giving presentations about their field of expertise and what they're doing. So I'm really happy to introduce our next speaker. The topic will be Scalable Electrolysis, the economy of numbers. And the guest is the lead scientist of Xintc. Please welcome on stage Dr. Ahmedreza Rahbari.
Thank you. Thank you. Thank you very much. So, welcome everyone. My name is Ahmedreza. I'm from the Netherlands. Xintc is a Dutch manufacturer of alkaline electrolyzers. So I will give a brief overview of our way of thinking about scalability, especially for electrolysis. First, a bit of background. We kind of see the hydrogen market as three separate sections. This is a bit our categorization. So the largest one is steam methane reforming. That's a very high capacity, high volumes of hydrogen for steam methane reforming. At the lowest part, we have the residential market, small volumes. In the middle section of the market, this is where we have kind of designed our product, because we see a lot of projects that they start small. They are decentralized systems, and they are coupled to renewable sources. So they require a good match with fluctuating energy sources. And they kind of start within the 150 kilowatts range, and they go up to 50 megawatts roughly. So these are not fully, but what we have defined as our operating range for our product. So what makes a difference between our product and typical alkaline electrolyzers is that we make gas modules. We try to lower the CapEx and OpEx as much as possible. And the way we do this is certain design choices that we consciously have made. So that the gas modules are made of high-grade plastic. There are no rare earth metals like other electrolyzer systems. We have embedded softwares, and these gas modules can operate basically dynamically, as I explain soon. So on the left-hand side, you will see a typical stack with metallic parts. So another advantage is that with the modularity, these gas modules can perform individual tasks, but they also work together. So if you have been to our booth, you may recognize this picture. We have sections of module electrolyzers, each of 150 kilowatts. And the advantage is that we can connect this directly to a DC source. And because of the modularity, we can dynamically turn the modules independently on and off. And in that sense, we can follow the fluctuations from solar fields without any DC-DC converters, without any PowerPoint tracking systems. And the scalability is very easy. Basically, do not make electrolyzer larger, but simply make in more numbers, larger numbers. Examples are solar fields, hardware data centers, batteries. So they are also use the same philosophy for design. So we have taken the same approach for scaling up electrolysis capacity. It can be used for DC source, AC source from grid or solar. All of these are possible. And this is specifically developed for projects in the middle section of the market where you can start small with some capacity and gradually you can scale up. Another example that I want to focus on is dynamic operation. So as I mentioned, because of the dynamic switching on and off of the stacks, we manage actually to remove some of the electronics between the solar field and the electrolyzer. DC-DC converters, maximum PowerPoint trackers. It's not needed because the embedded software and electronics in the electrolyzer can understand the power input that is coming from the field and the fluctuations. So it reduces the cost further by removing the electronics in the middle. So no optimizer, no DC AC inverter, no AC DC inverters from the solar field. And it actually allows us to capture normally the top 30% of the solar field, which is scaled to inverter. So we can get most out of the solar field and still the capex is lower. This is an example of a typical irradiance for a location I believe it is in Brazil. So it is a irradiance data of 1 day. So as you see, there's quite a bit of fluctuations for irradiation. And on the second plot, you see the fluctuations in power that's coming from the solar field. And a typical alkaline electrolyzer, big stack, normally cannot handle all of these fluctuations. It has difficulty following the fluctuations. But exactly because we have a modular system, at any given moment, our system can decide how many electrolyzers it can have operating. So by adjusting dynamically the number of stacks that are working, we can adjust maximize the mass production of hydrogen. So on the left, on the lower graph, you see how much hydrogen is being produced a day when there is a direct coupling to solar. So the system is really adjusted to capture most of electrons from the solar field and convert them to hydrogen. As I mentioned, modularity is not a new concept. However, for alkaline electrolyzer, we observed that we have a unique product which took this approach, combined with the material design that we have with plastic. We are able to mass produce this electrolyzer, so that further bring down the capital cost. You see the same examples in data centers, batteries, solar panels. As I mentioned, the end goal for us, we deliver a product, and the product should deliver the customer hydrogen for lowest possible total cost of ownership. It's not about maximizing efficiency of the electrolysis, it's about minimizing the cost of ownership. So how do we do that? As I mentioned, we standardize the parts. We can use automated manufacturing techniques, and we have carefully selected the supply chain within Europe. We work with European local supply chains, and we are also extending the market to Asia and America, and then we also look for strategic partners to make production locally and also distribute locally. We are located in the Netherlands. Our head office is close to German border in Eerbeek, and we have a scientific center for research and development activities. We are connected to the university in Delft, and we have a very heavy science foundation also next to our commercial activities. That's in a nutshell our activities. I'm happy to receive also questions. Yeah, thank you.
Thank you very much.
Thank you.
Such an interesting topic. I really like your idea that you directly look at total cost of ownership, because you mentioned, okay, efficiency, maybe we're not the best, but we're the best at total cost of ownership, and I think that's an interesting idea because many companies that produce really efficient technology say we do that to make it cheaper, but yeah, it's nice that there's another approach.
Yes.
I really appreciate that.
So what we are also doing differently, we try not to concentrate on a single parameter, such as efficiency. We have selected a variety of design choices based on supply chain, based on delivery time. For example, our electrolyzers will be delivered within 3 to 6 months lead time because everything is standardized. That makes a difference also at the end for the customer.
Yeah, I think it's a really good concept. So are there any questions from the audience? Anything you would like to know and ask our expert? It doesn't look like it, but I do have another question. You said it's so great because it's scalable. So you could start small, and then gradually scale up. What's your experience? how do people start? Like, what size do they start, and where do they go over
Yeah.
time?
So very good question. We are involved in around 10 projects in the Netherlands, basically, and this can be any small to medium-sized business. It can be chemical industry, farmers, mobility applications. For example, there are many farmers in the Netherlands that they already use solar panels and the batteries are not sufficient. So they want to basically store the excess energy in form of hydrogen. So, but they cannot start with a 1 megawatt or 5 megawatt project. They want to start somewhere and see how they can incorporate this into their process, like 150 kilowatts, 300 kilowatts, and then gradually, if things are working, they become familiar with how hydrogen is integrated into their process, they can scale up and they can add basically, as if they're Lego pieces, you can add them, scale up easily. And that's the strength of the system that is plug and play. So we can add modules next to each other and increase the capacity. So it makes it easier for the customers. Yeah.
Yeah, I repeat myself. I really like the idea and really interested. So in case you are interested as well, you can visit the company Xintc at their booth. It is B21.
Correct.
And thank you once again for being here.
Our contact information is on the last slide, so please feel free to contact us for more information. We are also on LinkedIn. So.
Perfect. Thank you. It was nice to have you here.
Thank you very much. Thank you.